So today we are going to find the moment of inertia and the product of inertia of a uniform rod of length 2a. So we are going to do two cases. First of all, we try to find the moment of inertia and the product of inertia about all the axes at the corner of the rod, and one is that we are going to find the moment of inertia and the product of inertia at the center of the rod. So first of all, we take the body of mass m, means we will consider the rod is made up of mass m. So the mass of the rod is nothing but capital M, and small m is the mass per unit length. The mass per unit length is equal to the mass of the body is capital M, so it will be m by 2a. Since the length of the rod is 2a, so the mass per unit length is nothing but m by 2a. So first of all, we consider a small element PQ. We are considering a small element PQ whose breadth is taken as delta x, or the thickness is delta x. So the thickness of this element is PQ is nothing but delta x. So I'll take one point C in this strip or in this element whose coordinate is nothing but x00, because the rod lie in the x-axis. So any point on the x-axis is given as x00. So the coordinate of C also will be nothing but it is x00. So I'm taking a point in the strip PQ whose coordinate is x, 0, and the mass of this point is taken as delta M. So we'll try to find what will be the mass, the mass of this point, small point, is taken as M. So I'm going to find what will be the mass of this element PQ, what will be the mass of the whole element PQ. So delta M is equal to mass of the element PQ. So mass of only one particle, in this element is small m. So the mass of the whole element PQ is nothing but mass into the thickness. So mass into the thickness, so we get m into delta x. So m is nothing but mass per unit length, so m by 2a delta x. And we can see that the distance from this element to the end of the corner of the rod is taken as x. Okay, the distance from the element PQ to the end of the rod is taken as x. So the x is nothing but the distance from the corner to the element PQ. So first we'll try to find the moment of inertia about the x-axis, that is taken as a. A is nothing but the moment of inertia about the x-axis. So by using the formula what we have given already, learned before, so that is equal to summation delta m y square plus z square. So we'll try to put the coordinate of y and z from this point. So if you put in place of y as 0 and z as 0, then we get here delta m. Here we get as delta m, we get as m0 square plus 0 square, which we get as summation m0 square plus 0 square, which is equal to 0. So same way we'll try to, so here the moment of inertia about the x-axis of the rod is 0. So we'll try to find what will be the moment of inertia about the y-axis. Now we'll try to find what will be the moment of inertia about the y-axis. So same way we'll try to put the coordinate of C here. So z is 0, we'll substitute in place of z as 0, then we get here nothing but delta mx square. So delta m is same as m, so we take here m by 2a into x squared dx. So m by 2a is, now how to choose the limit. Also we have to understand how to choose the limit. So when you look this rod, we are taking the axis at the corner of the rod. So the distance from this corner to the end of the rod is nothing but, if I take this as my origin, so this will be 0 and this will be nothing but 2a. So the distance from this point to this point is 2a. So the limit also will be ranging from 0 to 2a. So here the limit we are taking as from 0 to 2a, m by 2a x squared dx. So m by 2a is a constant, so if we come out of the integration and we have here 0 to 2a x squared dx, we'll try to integrate x squared. We know what is the formula, so it is very simple. We get here x cubed by 3, and the limit will be 0 to 2a. So we'll try to substitute the limit, and first of all we'll try to simplify this. If we try to simplify this, we should get here 4 by 3 ma square. So in that way we get here the moment of inertia about the y-axis for the rod is nothing but it is 4 by 3 ma square. And now we are going to find c, that is the moment of inertia about the z-axis. So moment of inertia about the z-axis, so we try is equal to summation delta m x squared plus y squared. If we put the coordinate of c here, we get 0, so we get summation delta m x squared. So that is same as equal to 0 to 2a m by 2a x squared dx, which is equal to 4 by 3 ma square. We have to follow the same procedure, and we get that the moment of inertia about the z-axis is also same as the moment of inertia about the y-axis, so that is 4 by 3 ma square. And we'll try to find the product of inertia about the different planes. So if we find about the OY and OZ, the OZ line axis, that is denoted by D, so if we get here summation delta m yz. So we know the coordinate of c was x0 0, so if you put the coordinate of y as 0 and z as 0, we get the product of inertia D to be 0. In the same way, if you put E is equal to summation delta m zx, so if we put the coordinate z as 0, we get here 0. And F is equal to summation delta m xy, so if we put sorry, here is x, y coordinate is 0, so we get here y to be here in place. So if you get here y to be 0, so just put here 0, then we get the f, then we get the product of inertia. F is nothing but 0. So in this way we can find the product of inertia and the moment of inertia of a uniform rod to be this. Okay, so second case we are taking at the center of the rod, we try to find the product of inertia and the moment of inertia. So first of all, we consider as an element PQ whose thickness is delta x, and we'll take one point there, so that I'll consider we are trying to find the moment of inertia at the middle of the rod. So we'll take an element PQ of thickness delta x, and we consider one point C whose coordinate is nothing but it is x, 0, 0. So the mass of this rod is capital M. Then we try to find it. So the coordinate, the mass of this point C is nothing but small m, and small m is nothing but the mass per unit length. So m is equal to m by 2a, which is m is the total mass of the rod. So we get here m by 2a. Okay, so in that way we'll try to find what will be the mass of this element PQ. So if the mass of this element PQ is nothing but it is m into delta x, that is equal to m by 2a delta x, which is we'll try to find what will be the moment of inertia about the x-axis, that is a is equal to summation delta m y square plus z squared. So we put the coordinate here 0 squared, so plus 0 squared, which is nothing but 0. And in the same way we'll try to find what will be the moment of inertia about the y-axis, that is summation delta m z squared plus x squared. So z is 0, so we put here 0, so we get summation delta m 0 squared plus x squared, which is nothing but summation delta m x squared. So now we'll try to understand how to find the limit of this. So here we have to take this, the middle of the rod. The middle of the rod we have to take as our origin. So if I take the middle of the rod as the origin, now the total length of the rod is 2a. Since the center of the rod is the origin, so on this side will be the length will be a, and on this side will be a. So it is nothing but, since it is lying to the left of the x-axis, the coordinate will be minus a, 0, 0, and on the right side will be nothing but a, 0, 0. So we can say that how the x values ranges from minus a to a, so that's why the limit is nothing but it will be from minus a to a. So here the limit is given to be from minus a to a, m by 2a x squared dx. So m by 2a is a constant, will come out, and we have to integrate x squared. So you know how to integrate. So after simplifying this and putting the lower limit and the upper limit, you get as 1 by 3 ma squared. So that is the moment of inertia about the y-axis for a uniform rod, about if the axis is passing through the center of the rod. And in the similar manner, we'll try to find the moment of inertia about the z-axis, that is summation delta m x squared plus y squared. Y is 0, so we put here 0, so we get summation delta m x squared. We have summation delta m x squared, so its limit is same, so minus a to a m by 2a x squared dx. So if you try to simplify this as what we have done before, we get the moment of inertia about the z-axis is equal to 1 by 3 ma squared. So in the similar manner, we try to find the product of inertia d, that is summation delta m y z. So we know that the code y is 0 and z is 0. We substitute that value, so we get here 0. In the similar manner, e will be finding that is nothing but summation delta m z x. So z is 0, so you put in the place of z 0. So if you multiply, we get zeros. So f is summation delta m x y. So y is 0, you substitute y to be 0, then we get the product of inertia f is also 0. So in the next video, I'm going to explain you about the product of inertia and the moment of inertia of a rectangular lamina. Thank you.